Hello, this is David Braun with Automated Valuation Technologies, and we're going to look at a situation here. A reviewer has a concern, and let's read it. I am reviewing an appraisal report that was performed to see what a new in-ground swimming pool would add in value to a particular home. The homeowner was trying to make a decision on whether to install the pool. The appraiser relied on simple linear regression analysis to extract the adjustment for the swimming pool. I recognize that this method is applicable to the problem. However, I am concerned that it may not be relevant as performed. This is based on the fact that out of the 20 sales analyzed, only 2 of them had a swimming pool. Okay, so this reviewer seems to be on top of things pretty good. The first thing the reviewer says is, I understand that the method that the appraiser is using to extract the adjustment, simple linear regression, is applicable. And what does applicable mean? Come down here. Applicable means that the method could work and it might return a reasonable output. Okay, it could work. So in this case, if someone directed you to use the discounted cash flow, would that be applicable? And no, because it couldn't work. It wouldn't work for this. What about the capitalization rate? No. So certain things just won't work. And if they can't work, no matter what, then they're not applicable. But a whole lot of things are going to be applicable, but they may not be relevant. So let's talk about relevant. Relevant can apply to data or analysis, and we usually think of it in terms of data, and it's okay to use it with data, but it also applies to analysis. So an analysis is relevant when it has a high probability that the analysis method will return a reasonable output. Okay? And that is partially comes from USPAP, where we talk about when we talk about something being credible, the outputs being credible, and credible means, in as far as USPAP is concerned, is worthy of belief. So what that means is that it's probably correct. So high doesn't necessarily come from USPAP, although you might stretch and say it's not credible if there's not a pretty darn good chance that the answer's right. Now, also, I'm considering is a legal definition for clear and convincing evidence. Clear and convincing evidence, evidence that establishes a high probability that the conclusion or opinion is true. So I'm also blending in credibility and clear and convincing evidence, because I think credible is very similar to clear and convincing evidence. So what would be a high probability if we could actually do probabilities? Now, if you think of probability, and over here I've got these, 0 to 100% is the probability range, but I like to start at 50%. Because 50% means it's like flipping a coin. So to me, that's where you start, okay? 50% just means it might be true. It could be true, it could be false. So we're going to kind of start there. Now, if you look between that range of 50 to 100, somewhere between probably 60% to 79% is a favorable probability. It tends to make you think that it might be true. It's probably not what I would call a high probability. A high probability is going to be something that is greater than or equal to 80%, like 90%, 85, 80 would be. When you fall down to 79%, then you have a favorable probability, but not a high probability. Now, that may be a little confusing because appraisers don't usually think of it that way. But let's think a minute. How are we going to help this appraiser Because what the reviewer is asking is that due to the analysis only relying on data where only 2 of the properties have the in-ground pool. So that's what we would call hits. Only 2 have it. So they're saying is asking the question, if you have 20 sales and 2 hits, 2 of them have swimming pools, will that give you a high probability? Or will it give you a favorable probability, or will it give you a 50-50? What will it give you? Now, the neat thing is that we can shed some light on this question, and that's what we're going to do in just a second. Now let's talk about the tools we're going to need. And so we're just going to stop and have a little commercial. This is the book that I wrote, The Valuation Analyst, Research in Extracting Adjustment Rates. And there's my name, David Braun, if you forgot who I was. And let's talk about, and up here you can see how to get hold of me. There's the website. There's my email. Let me mention on this website, right now we have a free software. It's called the USL Documenter. It helps you document your report, almost any type of report. Make sure you don't forget things, and also helps you write your scope of work. Probably probably is the best-selling product we ever had. It's free right now. I know you may be busy, but if you're busy, do like I do. Go to the site and download it so you'll have it later, because it won't always be up there free, but it's free right now. So go get it. And if you don't have time to fool with it, just save it and you can look at it when you have time. Now, let's talk about back to our problem. Some of the required tools in order to answer the reviewer's question. We're going to need to know a little bit about market modeling. We're going to need to know a little bit about the theory of probability. And I'm going to put here probability and chance. Kind of the same thing. But we're going to need to know a little bit about that. We're going to need to know about randomness or random variance. We're going to need to know what the law of large numbers is. And we're going to need to know about Monte Carlo simulations. Now, in this short video where we're going to try to shed some light and help this reviewer out, I'm not going to be able to go in depth into all of these. I may say a sentence or two, but that's where the book comes in. Now, this is over here is a little insert out of the book, or it's an illustration out of the book. And it talks about that a lot of what appraisers do, because I don't want you to get hung up and think this book is only for deep mathematical methods to extract adjustment rates. Now, it is for those, but it also goes to the other end of the spectrum as well. For example, we talk about an appraiser having training, experience, intelligence, and judgment, and those are kind of the 4 pillars for your foundation. Each of those, ethics can never be taken out of the picture. But when we think of these things, what is the difference in a personal trait and a method? Okay, basically intelligence, training, experience, and judgment are personal traits. They're not methods. And that's why sometimes when you're out in a really rural market and you say, I'm going to give this swimming pool $10,000, or I'm going to give it no value, whatever you give it, you say, and that's based on my training, experience, and judgment, okay? Now, that's not a method. You didn't describe your method. You described your traits. Probably your method in that case would be logic, and recognized economic principles could be your evidence. So you have logic and evidence. Your logic and evidence may be all you have sometimes in the rural areas. So if you described it, you would talk about you give the facts, and your evidence then would be recognized maybe economic principles, maybe diminishing rate of return, whatever it is, and logic. And that would be your methods. So this book is going to talk about these various methods. Now here's a table, and this isn't just an advertisement here. We need this to help that reviewer. This is a table out of the book, and it divides markets, property markets, into three major divisions, 1, 2, and 3. And each of those divisions is broken into two categories, A and B. So you basically have 6 different types of markets, okay? 6 categories, 3 divisions, with 1 being the most active and efficient, and then 3 would be very rural, and that'd be the least active and efficient, and 2 is in between. Now, in the book, it covers some of these at the top, which are definitely mathematical. Some of these are sophisticated mathematical extraction methods. And you got matched pairs, cumulative pairs, all the way down to logic-based surveys and interviews. All of that is taught. Now, the whole purpose of the book is to determine when the appraiser has met his or her due diligence when extracting adjustment rates. And what I'm finding is that the users of appraisers are asking for things that are not even possible. We hear about Fannie Mae's collateral underwriter. I don't know exactly what it does because I haven't seen it, but some of the things I hear that they tell you, like your adjustment rate's not right because it doesn't match their regression. And the book proves that if they didn't use the exact same sales and make the same other adjustments that you made, then that's not going to be true. So now let's get back to relevance. Relevant was an important concept. And so we're going to talk about the relevance. Now, one thing is I look up here at simple regression and I notice that in the book it says recommend it using multiple regression. Now, the reason for that is simple regression, remember, is when you have a sales price and only one property characteristic. In this case, it's swimming pool, in-ground swimming pool. You only have one. Now, that won't work if the house is varying in size, for example, gross living area 1,800 to say 2,400, or the ages are from 10 years to 20 years. If you do that, obviously none of that's adjusted. It's not going to work right. So what I'm recommending is by the time you would make all those adjustments, you would just bump up and do multiple linear regression. Simple regression is okay when the other property characteristics are all very, very similar except the particular feature you're looking for. Okay, so you can look at this chart to help right away to determine if some things are relevant. Okay, if some things are relevant based on what market you're in. Now, do we know what market we're in? They didn't tell us what market we're in, but we know they got 20 sales. So they got 20 sales. They're probably not in market category F, probably not even in E. So maybe we'll assume they're in market C if they got 20 sales, or D, because 20 sales is a lot of sales. And so we're probably not in a rural market, but it's not defined for us. Now we're going to start into getting some facts to help this reviewer. And there's a lot on here, so let me just start and go over it just a second. This right here, these columns, I guess it'd be just as easy to do them here. Okay, these columns represent, that I've just highlighted, a hypothetical market. Now, researchers sometimes make up a market because we need to know the answer so that when we run a method, we test it. Now, let me mention, and every time I go on a side note, I sometimes get lost, but the next USPAP for 2018 and 19, the next USPAP that's coming out has already got a advisory opinion about using automated tools to help you extract adjustment rates. And one of the things it says is the appraiser's responsible for knowing if they work. Well, this is one way you know that. So when you learn how to do a hypothetical market, and that's in chapter 2, if you have the book, it's in chapter 2, then you know the answers. So then you would make up some data, run it through whatever, for example, whatever tool you're using, and see if it gives you kind of a reasonable output. So that's one reason to do it. But now we're actually trying to calculate some probabilities. So what I've done here is I've set a pool. Now, a 1 means it has a pool. That's for yes. 0's for no. When you change yes to a 1 and no to a 0, that's called scrubbing the data. Scrubbing the data, that's in chapter 4 in the book. It talks about databasing and scrubbing. So a 1 means it has a pool. And we've made this model super simple. We have said that basically everything else is worth 300 and the pool's worth 30,000. So if you have a pool, you're going to, the value, the sales price over here, the I-P, which stands for intrinsic price, is going to be 330. Okay, so it's going to be 330. If you don't have a pool, it's going to be 300, right? Because you have 300 and that's all you have. So it's a very, very simple market. Now, this market then, this data here is called intrinsic. And let's go down. I thought I put something here. A virtual market results in an intrinsic value and or, and I didn't put it in there, it says coefficient, but intrinsic coefficient. So I know this is the intrinsic value. Sometimes you read, what does that author mean by intrinsic? Intrinsic means it's exactly correct because we built the model. So if you didn't have a hypothetical model, you probably don't have intrinsic values. So there's the intrinsic price. We know what it is. And this is a perfect model. So it wouldn't do good to check this because perfect data means there is no randomness in the data. Now let's define randomness. We know as appraisers, we're trained that if a house is worth around 100,000, it might sell for 90, it might sell for 110. We know that buyers and sellers have a lot of human psychological reasons that they might bid higher or lower or sell higher or lower. Could be as simple as a color. You know, it could be the way it's laid out. It could be a view. And the definition to us as appraisers for randomness is it's not predictable. We can't quantify it and predict it. So markets have randomness. And then I'm also going to mention that data sets have a randomness. Now, the degree of randomness in a data set is usually more than the data set because it also incorporates errors in the data. For example, if you have gross living area, calculate it wrong. The age on a few of them are wrong. Maybe there's a house that's a rental house that pulls it down, or a foreclosure that you think shouldn't be in there. Or maybe there's a house kind of in the area, but it really belongs in another market and it's way too high. All of these things we can't really quantify. And so they're random too. Our data is random. Now, the more that we work our data, the more that we maybe drive by our properties, call realtors, we can minimize this data randomness, this data set randomness. But you may hear me say randomness or associated with the market, but I'm probably meaning, when I get into this, I'm probably meaning data set randomness, which includes both the market randomness plus any errors, and the degree that you work that data and you verify that data is going to determine what that is. Okay, now we know that any analysis on perfect data is going to work every time. That's the problem when you take a class like on paired sales and you take an appraisal class and they use perfect data, it works every time. Then you take the data with real data and it's got randomness in it. It's scattered. Then it doesn't work so good. And we especially talk about that in chapter 1. We really look hard at finding the probability and looking hard at what we expect in the book, paired sales analysis, how good we expect it to work. Now, let's get back to this. So randomness, when you add the total randomness, it's the variation in the sales price that we can't explain. So we're going to add some. I actually have something here called a feature ran between, and it's ran between these two numbers up here, 0 and 0. Now, excuse me, let's put some numbers in here. Let's put -5 and a +5, and that's pretty good. If you only had a plus or minus 5% in the market, that's a very efficient market. So these come down in this randomness column random as a percent, okay? And we know that's the intrinsic value, so 4% of that is about 13.2. So the sales price we're going to use to be more realistic is going to be this. It's going to be the intrinsic plus the randomness. So you can see these are all going to be different prices in here, okay? Depending on on the amount of randomness. And so it's not either a -5 or a 5, it's anywhere in between, but it's going to be a whole percentage number. It could be -4, could be 0. And you can hit the F9 key if you use that ran between function. I'm going to just hit, see if enter works for me. No, enter doesn't work. Maybe it's delete. I can hit delete. Yeah, I'm not going to hit the F9 key because I think it pauses Camtasia Studio that I'm using to record this. And one time I showed this F9 key, then I talked for 20 more minutes and it was on pause the whole time. So fool me once. So I think, so now I'll just hit delete and you can see it calculates. So this is 326, 339. So this is going to rotate in that amount. We can't explain it, so it's randomness. So now it's more like a real market. Okay, so now what else do we need to know? Now I'm going to set this to where it only uses 20 sales. So this in the shaded area, for example, is not counted because in the reviewer said there were 20 sales, and remember 2 had swimming pools. So there they are, 2 had swimming pools. Now, let's talk and see if we can have a suspicion. I have a suspicion that the amount of random variance is going to affect the probability that this analysis method, which is simple regression, is going to function. I think it's going to have an effect. The number of sales is going to matter. The percent of the feature to the value is going to matter. Like this is 30,000 to 300. If this was 40 to 300, I think it would do better. And then, of course, the spread or the number of hits, whatever it would go by, or percentage. In this case, there's 2 hits, and that results in 10%, 2 of 20. Now, what we want to get is the answer using regression. Now, there's a few ways to do this. One is to go to data and then click on data analysis, and then let me drag this over so you can see it, then find regression. Okay, it's relatively easy to do. I'm not even really going to do it, but I'll show you in case you want to do it. I'm not going to bother to put it on. Well, I might do it and just put it on a new worksheet. It wants to know what the Y range is, and Y is always the sales price. Okay, so I'm going to click, let's just take the 20 is the sales price. X is the predictor variable or variables. In this case, we just have one. Whoop, I did sales price again. So let's come back and redo that. It's the, we want to do the pool. All right, and apparently I didn't get the Y range right because it says F6 and that says E7. So I'm going to start right there on the Y input. See if I get it right this time. There we are. Let's see, what I didn't do is I didn't do my labels. That was the difference. You could have done your labels. If you did, you would mark them. I didn't do it. We'll just put this in a new worksheet and see if it will run right here. I'm just going to say okay, and then there it is. And then right down here, the X variable, it came out, the answer with that particular amount of randomness, 14,500. Now let's go back to the pool. Okay, the real answer was 30, so it missed it quite a bit. How's another way to do it? Another way to do it would be to, let me take the sales price first. So I'm going to highlight it, hit Control. Then I'm going to take the pool and I am going to insert, oh, I took 30 of them here. Let's just take 20 of them. Then I'm going to hit insert or Control and take this. And then I'm going to hit insert and I'm going to hit chart. And it's going to give me kind of a funny looking chart because it's either pool, kind of yes, no pools or one pool. But what we want to see is we want to right click on this and add a trend line. And I'm just going to leave it, you can't see it very good, but what I really want to do is display the equation. So let's take the equation and let's see, the equation one now, because we have scrambled this since the last time, we see that the equation is y, which is the predicted price, is equal to $37,283 times the number of pools, which is going to be 0 or 1, plus 297,666. Now the 297,666 is the intercept, and that's represented really by the 300 up here that we used. That's the 300. How close did it get to 30,000 for the pool? 37. I like that. That's pretty good. Now, the third way to do this is simply to use, let me click on this, is simply to use the slope function. It's simply to use the slope because we know that the number in front of the x is the slope. Okay, so all we have to do is get the slope. Now, in a minute, in order to generate large numbers by use of a Monte Carlo simulation, we're going to try to do something 10,000 times. Going to get the data analysis that we use, that we put on the other sheet, or this chart's going to be a little slow. So we're just going to use the slope. That's all we want to do. Now, the next thing we have to decide, and I don't know what to use, but the next thing we have to decide is, if 30,000 is the intrinsic value, when would an extraction output, whatever you used, when would you consider it incorrect? Now up here I put 30%, which means that if it's between the range of 21,000 and 39,000 at 30%, we might say that's reasonable output. Okay, we don't expect it to give us between 28 and 32,000 to be correct. I would say this might be, but see, that's a wide range because if 30's in the middle of it, but if it's 21, now if you were using $100 gross living area, 30% would mean anywhere from 70 to 130. That seems a little high to me. Now, what if you put 20% here? What if we use 20%? 20% now says 24, if it gave more than 24 or less than 36, it would be correct. Maybe 25 is a good answer. That would be 75 to 125 if you were doing 100. Now that's 22.5 to 30. Let's use that. Let's use 25%. Okay, so what we're saying is, if we got returned something between this range, say 35,000, it would be correct. 23 would be correct. 33 would be correct. 40 would be too high. That would be, we would say, nope, it returned a bad answer. 20 would be too low. Okay, now what we can do is I have to hit, remember, the delete, and let's keep a couple of these. I'm going to hit delete and see how we do. I hit delete. It gave us 29,000. Is that in the range? Yeah, that's really good. So now we have one yes. Okay, I can write up here yes, or it worked, or no, it didn't work. All right, let's do another one now. I'm going to hit delete. Now it gave 20,000. Did it work? No, it did not work. So I'm going to put a 1 under no. And let's see if we can center these just a little bit. Okay. Now there's 2. Now I'm going to do another one. I'm going to say delete. Okay, it's 29,000. Man, that's really good. So we'll say 1, yes. Now let's do another one. I'm going to say delete. All right, 27. That's within the range. It worked. See that? It worked. Okay, now that's 4. Let's do one more and say delete. All right, and we got 36. That's in. All right, so we can see that in this case, out of 5, 4 out of 5, that's what is that, 80%? I think that's 80% was right. Now, the law of large numbers says if we do this thousands of times, the answer it gives here, right or wrong, how many times it's right or wrong, will be an accurate probability for doing one time. Okay, so all we have to do is do what we're doing here. Let's say 10,000 times and keep track of it and just hit them for 10,000 times. Now that's going to take me about 2 days. So what I've done is I've set a program up in Excel that it's going to run it once, and it's going to, if it's a yes, it's going to count it, and then it's going to run it twice, and it's going to see if this number is between these numbers, and it's going to count it, and it's going to do it for 10,000 times, and then the number of times it's right, it's going to divide by 10,000 to get a percentage. Okay, now if that doesn't make sense, again, it's all that's covered in the book, Monte Carlo and the law of large numbers. The law of large numbers is the theory. Monte Carlo is the method we're going to use to carry it out. So I'm going to change this to a -8 because we don't know, to a +8, what kind of market we're in. Now we're ready to actually ask the question, if you have 2 pools and you have 20 sales, 2 pools and you have 20 sales, what is the percentage at a -8 and a +8% market variance that you will get it right? If the value is 330 and the pool is 30,000, there's kind of your value ratio, and it's 44%. Now 44% is, when we talked, and let's go, and I'm going to say, okay, now this is going to put the 44 up here, so sometimes I want to compare. Let's go back in the beginning. What is 44%? Well, 44% is not even registered here because that means you're going to be wrong more often than you're going to be right. So you wouldn't want to tell a client that. How do you feel about that? You know, say, well, my record is I'm usually wrong more than I'm right. So that's terrible. So we know that's not a good probability of getting the right answer. Now, do we know from what was given to us from the reviewer what type of market or what type of random variance is in that market? And the answer is no. Do we know the pool and this ratio of the pool? And the answer is no. We don't know that. So can we ever give a definitive answer to that reviewer? And I would say no, we cannot give you a definitive answer. We can give you kind of an opinion. Now, before we stop here, let's look and see what we thought. Since we have this spreadsheet all set up, why don't we look at random variance? Remember I said that I thought if the variance got better, let's do -5 to a +5. Okay, there's less random variance. Now at 8, it would predicted a probability of 44. I think since we went down, we will have a better probability, a higher probability. So let's see if randomness affects this probability. Yes, it's 63%. Now we're in what we entitled, what did we entitle it? I'm going to click this 63.7. What did we entitle that? We called it favorable probability. So let me stop right here and say something before I forget it. If the only method, let's look at this table, if the only method that's going to be used is simple regression, I think it has to have a probability of about 80% chance to have a high probability. Once you hit that 80% chance, you know, meeting your due diligence, probably just that one method is good, okay, for appraisers. But is there any reason you can't do more than one method? No, there's no reason. And if you use multiple methods, then I think the 60% up is still useful. I don't like to use it as the sole, but I would leave the simple regression in if it's the probability I feel like is around 60%. You might use a cost-based. Okay, with a swimming pool, cost base is a little iffy because cost is not value, and that's especially true with swimming pools. Okay, then you could do survey and interviews. You could do some other methods, and if you used a couple methods, then 60% is good. Less than 60%, I wouldn't include it at all. Okay, now I know you're not going to always know what it is, but as we become analysts and as you read this book, I'm thinking over the next few years, appraisers are going to be able to think like this and understand this. Now, let me mention a second thing while I'm thinking about it. I have some customers that use some of the tools that I sell, and I understand for them in various areas, they have a pool. In my area, it's almost a pool, yes or no. But in some areas, apparently, the same price house might have just a pool. It might have a pool with a really nice landscaping and a great big pool house. Some of them even have pools and extra pools. They say a pool one and a pool two. If you're in those kind of markets, rather than doing that in quality, you could probably rate them like from none, 1 to 2, or from 1 to 3, and you could rate your swimming pools. So be aware of that. It's not always a 0 and 1. If you go to somebody's property and they have a pool, a smaller pool, a heated pool, and a large pool house, that might represent a 3. So that's beside the point. I just wanted to bring that up. I always like to throw things out. Now, let's get back. What about the number of sales? Number of sales. I think that the more sales you have, the better. Now, we just ran 20 sales with 2, okay? Now let's go, but we want to be the same percentage. We're going to leave the percentage the same. It's going to be 10. So let's use 30 sales, which is more sales, and let's add 1 has a pool. So now we have the same percentage, 10%, but we're using more sales. I think we'll get a higher probability than 63.7, okay? Because we've used more sales with the same ratio, with the same percentage having pools, and we did. Look there, 75.1%. So we're able to use this to prove some general ideas. What about the percent feature to value? Okay, we just got 75 with this, just to make it easy. If I make this 20,000, let's go the other way. Now that's lower than this, so it's a less magnitude. Think about if these adjustments are hiding from you, the smaller they are, the harder they are to find, okay? It's just a little rule there. So I think because we made this worse, the probability of success will be less. We'll be right less times. So I think we'll be less than 75% probability. Yes, way less, 57.5%. So the magnitude of what you're looking for, and in the book I talk about a 10% rule, and you can read about that in the book when it's 10% of the value without it. Now, what else do we need to do? We did the percent. Now, the spread of the number of hits. All right. Now, if I add a couple of hits, okay, to what we just ran, but there's more hits, and we don't want to go over 50%, but I added more hits, I think we'll have a higher success rate, don't you? So let's test it. I think so, but I want to test it. And yeah, it's higher. See how it went up. So far, we've proven how these affect our value. So that's important to know. So that's really good information for us. And what we're doing is, if you'll notice what I just did, I didn't just read in a book, or I didn't just tell you off the top of my head. I think that as the random variance gets worse, we're going to have a harder time extracting our adjustments in this case, okay? What did we really do? The key word in the book is research. And that's what I've tried to do in this book, is provide mathematical evidence. So if you tell a reviewer as an appraiser, or if you're a reviewer and you tell an appraiser something, if it's out of this book, most of it has been mathematically proven. So you don't have to argue about it. They're not necessarily facts, but they're close to facts. But the one thing I want to tell you, we call this, what I'm doing, empirical evidence, okay? This is empirical evidence of what we've said here. That's empirical evidence. One of the key traits of empirical evidence is that it's repeatable. In other words, if one of you tested this, you should get about the same answers that I'm getting. And don't ask me to send you my spreadsheet, because that would be a bad test, because you're using my spreadsheet. And if it's wrong, you're going to have it wrong too. You're going to have to use your own spreadsheet. Okay, so what else do we have to cover? Well, we want to answer the question, is with 20 sales, is there a problem? Is the reviewer concerned? Now, the reviewer didn't tell us if that's the only method they used. So let's come back and give a general answer to this reviewer, okay? Because I'm going to come back here and put -8 and 8, or maybe make it as good as it can be. Let's do the -5 and a 5. And let's get to where we only have the 2. Just let's set this back up. Okay, now we only have the 2 and we have 20 sales. Okay, we're not using these darkened out, we're using 20. All right, what is the probability? And we don't know the price of the pool. We're going to put 30,000. And so we've kind of used optimistic things, pretty good market, and the pool 10% rule. So let's hit go. So kind of the best we would expect. And remember, this is not real data. It's better than real data because it's just 300 for everything else. Okay, if the best it can do is probably and I'm going to go back to what we called it. I want to say not favorable probability, but not a good probability. Okay, which means in that case it would be useful if it's a second or third extraction method. But let's go to -8. Let's say he's in a little worse market, or she, this appraiser, didn't tell us to he or she. And let's say this pool is only worth 20,000. What kind of probability would we see? Could we see? We don't know this information. 32%, that means there's a 70% chance that it's wrong. 70% chance it didn't return within 15 to 20,000. So what I would answer in general terms to this reviewer is, I do not have enough information to give you a definitive answer. However, I am suspicious of only having two out of 20 sales, only having 2 that had swimming pools. I'm very suspicious of that. So I do think that if certain markets, it is possible that that method, with the data that it used, could be relevant as long as it's used in conjunction with 1 or 2 other extraction methods. Okay, I think that's covered everything that I wanted to and more. So if you think of anything else or any comments, please shoot them to me at my email. Thank you.